Welcome to Brain Vision.
So we're told about a situation and we're asked why this is impossible. The first thing we're told is that the width of the machine is longer than a professional basketball player. I'm saying that some of the tallest professional basketball players are a little bit over 7 feet tall. So I'm going to go with 7'2", which is 7.16 approximately. I guess it's more like 7.17 feet. So we have a spring constant of 1.2 newtons per centimeter. But it's inclined, the surface is inclined 10 degrees. And we know that the initial compression is 5 centimeters. Well, force equals kx, but in this case, the compression is d, so force equals kd. And the ball has a mass of 1/10 of a kilogram. Well, one way that I'm thinking about handling this is that the potential energy of the spring is 1/2 kx squared, which is d in this case. So we can figure out the energy of the spring. I'm just going to put that into a calculator. 1/2 times k, which is 1.2 newtons per centimeter, times 5 centimeters squared. But just to be safe, I'm going to convert these into meters. That would be 0.0500 meters. And newtons per centimeter, I know there are 100 centimeters in a meter. So for K, I need to multiply by 100. That would be 120 newtons per meter. So 1/2 K is 120. X squared, X is going to be 0.05 squared. That's going to give me 0.150 joules. All right, so I'm thinking that as I'm considering this problem, it didn't really mean that the width was greater than or equal to 7.16. I was thinking about a pinball machine like this. And I was thinking about the person being up here laying this way. But that's not what they mean. They mean the person could lay like this. All right, which means that the length of the machine is at least 7.16 feet. There's 3.281 feet in a meter. So 7.16 divided by 3.281, that's what they're saying is the length. All right, now this makes sense. So if this were the case, then looking at the side view of the pinball machine, like this, this is theta, which we said was 10 degrees. This distance is greater than or equal to, I'm just going to do 7.16 divided by 3.281. 2.18 meters. Okay, that would mean that this height here would be greater than a certain distance. The sine of theta is the opposite, which would be this distance, over the hypotenuse, which would be the 2.18. So if I take this 2.18 and I multiply by the sine of 10 degrees, then assuming I have my calculator in the right, no, I don't have my calculator in the right mode. Give me a negative number, so I knew my calculator was not in the right mode. Okay, let's try this again. No, that's not going to work. All right. So I'm doing 2.18 times the sine. What is my problem? 2.18 times the sine of 10 degrees. That's going to give me the height, which I'm going to erase up here, is greater than or equal to 0.379 meters. All right. But we know that the energy is 0.150 joules. So mgh is 0.150 joules, ignoring friction. We know the mass of the ball is 0.1, and we know what g is, it's 9.81. So h that the ball can reach is going to be this 0.150 joules divided by m times g. So let's put that into a calculator. 0.150 divided by m, which was 0.1, I believe, times g, which is 9.81, the maximum height that it can reach is 0.153 meters, which is much less than the 0.379 meters. So the spring pulled back that far does not have enough energy stored for the ball to be high enough to go into to reach the top of the pinball machine, or even near the top of the pinball machine.